To assist with the use of the performance solutions, BCA 2016 includes two new verification methods. You'll recall that a verification method is one way of demonstrating that a performance solution meets a performance requirement. This is not the new way that it must be done. It's an option which might suit your project better than other compliance methods available in the BCA. The first new verification method is for structural robustness. This verification method is directly linked to performance requirement V2.1.2 in Volume 2, which in a nutshell requires that if part of your building structure breaks, the damage shouldn't extend beyond what is reasonable for that building. For example, if a column in a car park breaks, the whole car park must remain stable. In fact, the other columns around it should have capacity to share the load and prevent damage from extending too far. How far is too far? That's where the new verification method comes in. The new verification method has two parts. The first part, A, says that if your structural engineer models the building and takes out any of these things, a column, a beam, supporting or more columns, or a segment of a load-bearing wall, as long as it's tall, then the building must remain stable and collapse must not extend beyond the immediate adjacent stories. The next part, B, is a concurrent requirement to A. This one points out that if you have a structural component carrying more than a quarter of the structure, then special attention is required to ensure that the critical load paths are identified and robustness of those load paths are considered. The next new verification method is V2.4.5, ventilation. The performance requirements to which this verification method in Volume 2 is P2.4.5. This performance requirement is about ventilating a space within a building so that acceptable indoor air quality is achieved. In quantifying this performance requirement, Table V2.4.5 nominates the maximum contaminant level permitted. It lists the pollutant, the maximum amount allowed, and the period of time over which you measure that pollutant. So for example, right now we are all breathing out carbon dioxide, which is the first row in the table. As measured over 8 hours under this verification method, this room we are in cannot contain more than 850 million parts of carbon dioxide. As measured over 8 hours under this verification method, this room we are in cannot contain more than 850 parts per million of carbon dioxide, and fresh air is to be introduced at a rate which enables that. In Volume 2, the table only applies to Class 1 buildings. We already rely upon computer modelling in fire engineering for smoke exhaust and occupant egress, and there is some excellent software available for that. There is also software already available for modelling contaminant levels. These screenshots are from one such software package. This can be used by an appropriate professional to demonstrate that a ventilation design complies with the new verification method. This new verification method allows a refined mechanical design tailored especially for a given building. Engineers can use computer modelling to come up with innovative solutions which reduce cost and energy consumption.